Energy is a notoriously tricky thing for us to define. It's something that we sort of take for granted all around us. We eat food and we get energy for our bodies to move and to do stuff. So perhaps the easiest way to think about energy is it gives us the capacity to do stuff. Gives capacity to do stuff. So physics, if you like, can be interpreted or can be looked at as a study of energy and energy movement and flow and transference and all that kind of stuff. But anyway, coming back to energy giving us capacity to do stuff, work is how that energy is transferred from one form to another. It's not strictly speaking correct to describe energy as something which you can use. So you shouldn't talk about using energy. It's neither created nor destroyed. It's conserved. It just changes form. So you could have, like according to the next little section under here, we've got potential energy in the form of gravitational potential energy, lifting something up like a brick, and that's now got stored gravitational potential energy. If you let it go, it'll fall back down by itself and release that energy. You can have chemical energy, chemical potential energy stored. You can, in like the food that you eat, that gives you energy to move your muscles, which then becomes kinetic, which is just below there. And elastic potential energy can be energy stored in a spring or a rubber band that's stretched or compressed. And going back again up to this idea of work, work is what's done to transfer or change the form of that energy. So for instance, you can push a car and you have taken the chemical potential energy and you've converted that from your body and your food and everything into kinetic energy by making the car move. So kinetic energy is moving energy, really important. We'll look at a couple of formulas for this shortly, and there's one last thing which is important, is the power. Power is the rate of energy conversion. So if you have let's say cars, people think about cars a lot. If you have a fast accelerating car, that generally has the ability to convert more energy per second. So we actually have a formula related to power. Power is the amount of energy converted over time. You could also say it's the work done over time. So yeah, say you're moving bags of sand and it takes a certain amount of energy to move one bag. If you move 10 bags in 1 hour, you've used less energy, and your rate of use of that energy has been lower compared to someone who moves 10 bags in 2 minutes. So the higher power output is someone who can do more work over time. And yeah, you might like to think of work in a more of an academic sense, where you're thinking and you're performing mental work. But physics, we tend to talk about actual physical objects and mechanics. Yeah, formulas. Let's look at the formulas really quickly. We've got, there's actually lots of them, but so we're just going to mention a couple. Gravitational potential energy, E subscript P with grav, so we know it's gravitational potential energy, is mass that you're raising times the force due to gravity times the gravitational field strength, that is G, times height. So these are the things which affect the amount of energy in gravitational potential energy. So a larger mass that you lift up will have more stored energy. If you go to Jupiter, which has a much higher gravitational strength, and you lift an object up the same distance that's the same mass, then it'll obviously be more energy stored in there. It'll take more effort too, which is where the energy comes from to do the storing. And if you move a brick twice as far up, so increasing the height by 2, that'll obviously impact the potential energy stored as well. I'm just going to leave elastic for now, because that's got some interesting things to look at. Kinetic energy is also a very classic formula, half mv squared. So if you double the mass of an object that's moving, it has double the energy. That means it would take twice as much energy to stop it. If you double the velocity of something moving, however, it's going to, because you've got the squared factor in there, that's going to not just double it, but by a factor of 2 squared will increase it. So if you have 3 times the velocity, you're actually 3 to the power of 2. So it's times 9 the energy stored in that moving object. Okay, so hopefully that gives you a quick intro to energy. Yeah, tricky one, very tricky one to talk about. Oh, very important, energy is symbol E, measured in units of joules. Joules. Okay, I'm not sure, sometimes capital J, sometimes small j, but the symbol should be a capital J if you're talking about joules.